I'm just going to jump right into these notes. I'm going to try to keep the video nice and short and sweet. We kind of introduced today the new topic, which is thermochemistry. We talked about how thermo means heat, so we're dealing with heat and energy in chemistry. So real simple, thermochemistry is the branch that deals with energy transfers from reactions in the surrounding environment. Okay, is energy that is absorbed or energy can be released or absorbed from a chemical reaction. Okay. Heat is energy that is transferred. All right. We do not say that something is full of heat. If I have a glass of hot water, it has a lot of energy. It doesn't have heat. If I warm the water up by putting it in a microwave, then there's energy being transferred into it. That is heat. It is gaining heat. Heat is energy that is in transfer. It is moving from one source to the other. If it's just sitting there, that's not full of heat. That is full of energy. It's kind of a small difference, but it is important that we realize that. Okay? Don't confuse heat, energy, and temperature. When something absorbs, transfers energy, that is heat. It's transferring it. Its temperature may change, but it also may not. And we'll talk more on that later. Okay. Energy is measured in joules or calories. Both of these are units for energy. Now, it's not the same calories that you'd read on the nutrition facts on a box of food or anything, or something like that, but it's similar, and we'll talk about that later. Okay. It is very important that we remember the identity of these two different terms, the system and the surroundings. We introduced this term in class today. That's what the system is. You've got to make sure you understand this definition. The system is whatever we're looking at, okay? What we are focusing on. The surroundings is everything else around it, okay? You've got to know the difference between these. So maybe if I give you an example problem, this right here, I'm going to say, okay, this cup contains this many milliliters of water. It's been heated up to a temperature. What is the system and what is the surroundings? Well, in this particular problem, we're heating up the water. We're focused on the water. That water is our system. This is what we're working on. And the surroundings would be like the environment around us. Or maybe if it's in a microwave, then we're talking about the microwave as the surroundings. But the system that we are focused on is the water. Maybe in another example, now I place an ice cube in this hot water and I watch it as it melts. What's the system and what are the surroundings? Now we are focused on the ice cube. We are watching it melt. We're observing the temperature. We're observing the energy that's happening. We're focused on the ice cube. So the ice cube is our system. What is its surroundings? Well, in this case, the surroundings are the water. That is what is going on around it. That's what's the energy transfer. That's where it's coming and going. So the ice cube is our system, and its surroundings are the hot water that we placed it in. It's important that we have these terms down, okay? We know the ice is going to melt in that last example. So what is happening to our system? All right? Well, we know that the ice cube melts because it heats up. It's getting energy, okay? Well, that heat is leaving the hot water and transferring into the ice cube. And as it absorbs enough energy, it will eventually melt. So let's introduce a new vocabulary term here. Enthalpy is the change in energy of a system. When we measure the amount of energy the ice cube absorbed, or if we measure the amount of energy that the water released, we are measuring enthalpy. It's a change. And the variable for enthalpy is delta H. This right here, this symbol, the triangle, is delta. Delta H is enthalpy. Okay? Even in our cup of hot water, energy doesn't disappear. Okay? If we leave the cup of hot water, it will eventually cool. It does not disappear, guys. Energy does not go away. It is absorbed into the surroundings, which is why a very important fact that you will want to write down right underneath that definition of enthalpy, you will want to write this down. Energy cannot be created or destroyed. It can only be changed. We can change where it's located, we can change its form, but you cannot create or destroy energy. That is the law of conservation of energy. It is very important. Energy cannot be created, energy cannot be destroyed. Okay? If our system is the hot water, it will eventually cool and it will lose energy. Now, I really want you to pay attention to the difference of these words here. If a system loses energy, that is exothermic. The enthalpy will be negative. The enthalpy will be less than 0. If energy is leaving our system, that is exothermic. But if our system was the ice cube, it's warming up, it eventually melts, it's absorbing energy, the system is gaining or absorbing energy, that is said to be endothermic. Our enthalpy will be positive, so pay attention. Notice it's the same setup. We have a cup of hot water with an ice cube in it. If I'm paying attention to the cup of hot water, that water is cooling off, it's losing energy. This is exothermic, losing energy. It's exiting. But if we're paying attention to the ice cube is absorbing all this energy from the water. It's causing the ice cube to melt. It's gaining energy. Energy is entering it, and it's endothermic. So is your energy exiting or is it entering? Exothermic, endothermic. Okay? So let's take a look at a couple of examples. I have a bowl of soup that's on the counter, sitting on the counter, and it will eventually cool. Is this endothermic or exothermic? Well, if our system, the soup, we're watching it, it's cooling, it is losing energy. Remember, if energy is being lost or if it's exiting, that is exothermic. So this situation is exothermic. Now, the next one is going to be a little more in-depth. It's going to be a little more chemistry related. When we pour sulfuric acid into water, remember it's always acid into water, A and W, acid into water, because we're wanting to dilute it in the previous units. Okay? The water, the beaker, is going to get warm. This is why you pour acid into water. It's going to get warm. The acid is breaking apart, it's dissoluting, and so something's happening there. Well, this beaker of water, our system, is that endothermic or exothermic? Well, if the beaker of water is getting warm, then it's getting energy. It's gaining energy. Energy is going into this. Well, if energy is entering our system, that is endothermic. Okay? And this is where it really gets new and where we're going to have to spend a lot of time. Okay? Because where did that energy come from? You can't just make energy. Well, since we're pouring that sulfuric acid in there, and I use the term dissolution, it's breaking apart. The sulfuric acid is breaking apart into the hydrogen ions and the sulfate ions. Since that's happening and those bonds are breaking apart, they are releasing energy into our system, which caused the water to warm up. Now, don't worry if that was just a little bit past you. That's okay. We're going to spend some time working on this, so I don't expect you to have this all completely 100% mastered right now. What I do expect is that you have your notes in class tomorrow so we can get started on some practice. I will talk to you guys tomorrow. Y'all have a good day.